Good morning, Year 6. I hope you're well and keeping safe. So today is the 2nd of June 2020 and our learning intention today is to solve one-step missing number equations using inverse operations. So you'll see I haven't written today's date in Roman numerals. Let's see if you can remember what it should look like. So writing down today's date, our date in Roman numerals and our learning intention. Off you go. Fantastic. So hopefully you've written the correct date in Roman numerals. You can check it on the screen and we'll begin our lesson for today. So as usual, for today's lesson you'll need a pencil, paper, 5-minute timer, and you'll need your thinking hats on. So you'll need your brains working and ready to learn. Check. So for our starter today, I'd like you to set your 5-minute timer. And to be honest, I think this probably won't even take you 5 minutes, but it's there if you need it. And I'd like you to have a go at solving the calculations shown on screen. Think about the most efficient way to find the answer. Remember to pause the video. And let's go through the answers. So 8 times 9 equals 72. 8 times 7 is 56. 18 times 6. Now you could have done the formal written method, or some of you might have remembered I said you can halve one number and double the other. So if you halve 18, you get 9, and if you double 6, you get 12. And what's 9 times 12? That's right, it's 108. 216 divided by 18. So you need to work out how many 18s there are in 2. That's easy, there are none. How many 18s are there in 21? Yep, that's right, just 1. And that means there is 3 left over. So then how many 18s are there in 36? Yep, that's right. There is 2. So our answer there is 12. 12, and you can do the inverse to check your answer. So 12 times 18 equals 216. Now next one, 7 plus 9 times 4. So if you did 7 plus 9 first, then you are incorrect, I'm afraid. You need to remember the order of operations. We use BIDMAS in our school. So that's 9 times 4 comes first because there's no brackets, indices, division, but there is multiplication, so we do that first. 9 times 4 is 36, and then 36 plus 7 equals 43. 5/8 of 48, so we need to do 48 divided by 8. What is 48 divided by 8? That's right, it's 6. And then we multiply it by our numerator. So 6 times 5 equals 30. So our answer is 30. Moving on to question number 6. 70%, question number 7, my apologies. 70% of 90. So 10% of 90 is 9, because we do 90 divided by 10 and we get 9. Now we know what 10% is, we can use that to help us find 70% by multiplying it by 7. So to get from 10 to 70, we multiply by 7, so we do the same with our 9. And 9 times 7 is 63. 1.2 plus 4.7. Well, this is a simple one. We can just add together our whole numbers first and then our decimal numbers. So 1 plus 4 is 5 and 2 plus 7 is 9. So we get 5.9. Whereas for the next one, it's a bit trickier. So we can ignore the decimal first. 36 plus 36 equals 72. And then remember to put our decimals back in. The decimals in the question was 1 decimal place in, so we need to do the same within our answer. For number 10, we're going to do 3 cubed. So that's 3 to the power of 3 means 3 cubed. So 3 times 3 times 3. 3 times 3 is 9, and 9 times 3 is 27. So our answer is 27. 4.9 times 10 equals 49. So our answer is 49. 3/8 times 5/6. Well, we do 3 times 5 and we get 15. 8 times 6 and we get 48. And then if we simplify that, the highest common factor is 3. So 15 divided by 3 is 5. And 48 divided by 3 is 16. We know that 48 is a multiple of 3 because 48 is a multiple of 6. And if it's a multiple of 6, it must be a multiple of 3. Well done if you managed to get those. Now let's go on to solving one-step equations. So to find the value of x, we can use inverse operations to isolate the unknown so that it's on its own on one side of the equation. Now that word inverse, we've talked about it before the holidays. Pause the video here and just tell somebody else in your household what the term inverse means in math. Excellent. We know that inverse tells us, it helps us to undo an operation. So for example, addition and subtraction are the inverse of another. If I add something and I do the inverse of it, it means I'm then subtraction. It undoes the operation which we've just done. Multiplication and division are also inverse operations. So if you have a look at the equation shown on screen, we've got the expression shown on screen, we've got x plus 5 equals 9. The inverse operation is to subtract 5. Instead of adding 5, we're going to subtract 5. And we must do this inverse operation to both sides of our equation. So if you have a look at the balancing scales shown on screen, we know that a balancing scales tells us that both sides are equal. Otherwise, one side would be higher than the other. Have a look at the one shown on screen. Are both sides equal? Yes, they are. We know that x plus 5 is equal to 9, and we can use that to help us, remembering what we know about the inverse. Instead of adding 5, we're going to subtract 5 from both sides of our equation. Minus 5, all gone. Now you can see what we have left. What we have left is the value of x, because we had to add 5 to x to get 9. Now if we take that 5 away, all we have left is our x. You can see on the left side, that doesn't tell us much. It tells us we have x's left. On the right side, it tells us that x is equal to 4, because we have 4 left. So now we know that x plus 5 equals 9. The value of x is 4. Well done if you managed to work that out super quickly. Now we're going to move on to the multiplication sign, which is not used in algebra, and the reason being is that the multiplication sign can become a bit confusing when we're also using the algebraic x. So instead, the number that we're multiplying by is put before the letter. For example, we could have 2x, which means x multiplied by 2. Okay, so we don't use that times symbol in our algebraic equation. The operation in this expression shown on screen, you'll see 3x equals 15. It means 3 times x equals 15. We need to use our inverse operation. What is the inverse of times or multiply? Excellent, it's division. So instead of doing 15, instead of doing 3 times x, we need to divide it, and we're going to start from our 15 working backwards. So we do 15 divided by 3. Now, what we have in those three groups will tell us the value of x. Voila! Can you see our three groups? Excellent. How much do we have in the three groups shown on the right-hand side? Excellent. We have 5 in each of our three groups. So 15 divided by 3 gives us 5. So x has a value of 5. Let's have a look at a one-step number riddle matchup. And we're going to have a go at matching the word problems to the correct representation. So we can see here, I think of a number, then I triple it, and my answer is 18. Which of our bar models shown on screen represents the problem? I think of a number, I triple it, and the number is 18. Pause the video here and try to work out which bar model represents the problem. Excellent. We know that the total is 18. The number that we're thought of, when we triple it, we get 18. And if we're tripling a number, it means that that number we're adding to itself 2 more times. So each time it has the same value. So the answer here is the first one. Okay? See if you can use that to help you work out what the number is that I was thinking of. What will you use to help you? Excellent. Remember, we tripled it. So that means we multiplied it by 3. So if we want to find out what the number is that I was thinking of, instead of multiplying by 3, we take our answer and we divide it by 3. And that gives us 6. So the number I was thinking of initially was number 6. Now have a look at the other problem shown on the screen. I want you to have a go at writing a number riddle to explain what the 2 other bar models represent. So can you think of a number riddle for the other 2? Pause the video here and write them down. Excellent. Did your riddles look like this? I think of a number, I add 3, and the answer is 18. So this one's if your number, you've added 3. So 15 would have been your number. Or I think of a number and add 9, the answer is 18. What is my number? So that one you'd have to do 18, instead of adding 9, we do the inverse, subtract 9. 18 minus 9 is 19. So that's the number that we were thinking of. Let's have a go with another one. I think of a number, I add 5, and the answer is 23. Which bar model represents the problem? Pause the video here and work it out. I know. Did you think it was the first one? Not quite. I know, you thought it was the last one, didn't you? Not quite. Well done if you thought it was the second one. Thinking of a number, so that's the number we're thinking of is unknown, that's our question mark here. Add 5 and we get 23. That is shown in the second bar model. And to do the inverse, to find out the value of the number that I thought of, we do 23. Instead of adding 5, we're going to, that's right, subtract 5. 23 minus 5. Now, I wouldn't expect you to be using your fingers here. You should be able to work that out quite quickly. 23 to 20 is 3. Take away an additional 2, equal 18. So the number I was thinking of was 18. Now, just like with the last one, I want you to write a number riddle to explain what the 2 other bar models represent. Pause the video whilst you write those down. Excellent. So you could have had for the first one, I think of a number, I multiply it by 5, and the answer is 23. So you've got a number there, all the same number, been multiplied by 5, and the answer is 23. And in order to solve that, you'd need to do the inverse of multiplication, which is excellent division. So you do 23 divided by 5. Now before you even do that, I want you to think, is it going to be a whole number? No, of course not, silly. It can't be a whole number because 23 is not a multiple of 5. So we know if we're doing 23 divided by 5, we're going to have a decimal number. And for the last one, I think of a number and I add 20. The answer is 23. What was my number? So I added 20, 23 minus 20, and what do we get? Well done if you managed to work those out. Now, I'm going to try and get a little bit more challenging. So now we're understanding what one-step equations are and how we can use the inverse to solve them. I want you to compare the value of x and y in these equations using greater than, less than, and equal symbols. So you can see we've got x plus 3 equals 24, and then y minus 15 equals 7. I want you to first of all work out the value of x, work out the value of y, and then use the greater than, less than, and equal symbol to compare them. So the first two horizontally, they are a pair, and the second two horizontally, they are a second pair. Okay, so find the value of x and then y, and then use the symbols. Pause the video whilst you work them out. Excellent. Now let's go through the answers. So for the first one, we can do 24, and instead of adding 3, we're going to subtract 3, which gives us 21. So x has a value of 21. Now for the second one, instead of doing minus 15, we're going to add 15. 7 plus 15 equals 22. So 22 is the value of y. Think about what symbol needs to go in the middle there, which is greater, 21 or 22. I know that's a tricky one, isn't it? I bet you all got that right. I bet you've all put the correct symbol in between. So it should be the greater than symbol facing the 22. Then for the second one, we've got 4x equals 32. Now we know 4x really means 4 times x. So instead of timesing, we're going to divide. 32 divided by 4 is 8. So x has a value of 8, and we can go back again to check. 4 times 8, yeah, that gives me 32. For 5y equals 35, we know that 5y is the same as 5 times y, and to do the inverse, we need to divide instead. We can't divide by y because we don't know the value of y, but we can divide by 5. 35 divided by 5 gives us 7. So what's greater, 8 or 7? I know, this is so tricky. 8 is greater. Well done if you got that. So in balancing this equation, we can see that x equals 85. And Nishi says, I can balance this equation using the expression 100 plus 60. Do you agree with Nishi? Pause the video here and write down your answer. So Nishi is incorrect, because if x equals 85, then 2x equals 170. So it tells us on this question that x is 85. So we know one of these blocks is worth 85. But we've got 2 of these blocks, so 2 of them totals 170. We can work that out quickly by doing 2 times 80, 160, and 2 times 5, which is 10, and adding our answers together. Nishi says that 100 plus 60 equals 160, but that doesn't balance out our equation. Okay? We know that we would need to make 170 to balance this out. So, sorry, Nishi, but you're wrong this time. Now I want you to have a go at writing 3 different expressions that will balance this equation. Pause the video whilst you do that. Excellent. So you could have had 200 minus 30, 190 minus 20, 17 times 10. You could have had 34 times 5. There are a number of different alternatives that you could have. So well done if you managed to get anything that totals 170. Now the total height of all 4 sunflowers is 2.1 meters. So that's the same as 210 centimeters. Sunflower A and B are the same height. Find the height of sunflower C. I think this is a really good question because it shows us that we need to use the information showing on screen and gradually chip away until we can get to our answers. Now, we actually only know outright the height of one sunflower. Which sunflower is it? Super. We know the height of B. We can use that to help us then find the height of A. Once we found the height of A, we can use that to help us find the height of D. And then we can use that to help us find the height of sunflower C. So pause the video here whilst you work out your answers. Remember, you're finding the height of sunflower C. Excellent. So, we know B is 66 centimetres. So we know that X plus 35 equals 66 because we know that A and B are the same height. So we can use the inverse to help us find the height, the value of X in A. So 66 minus 35 gives us, that's right, 31 centimetres. So now we know that A is 31 plus 35. So now we know the value of X, and we know that X equals 31. We can use that to help us with sunflower D. 80 minus 31 gives us 49. So now we know that sunflower D is 49 centimetres. Now, sunflower C, well, for sunflower C, we've got 210 minus 66 plus 66 plus 49. And you might think, but wait, where do we get our 210 from? Well, go back to the original question and look at what we know. We know that all of the sunflowers together equal 2.1 meters, which is the same as 210 centimeters. Now, because the others are being measured in centimeters, we need to make sure we're comparing them using the same measure. And it's a lot easier when we do our calculations. So 210 is the total of all 4 sunflowers. We know the height of A, we know the height of B, we know the height of D, but what we don't know is the height of C. Surely if we took away all of what we do know, then that will only leave us with what we didn't know. So we do 210 minus the 66 that we knew about, plus the other 66 that we knew about, so that's A and B together. And then we also need to minus the 49 from sunflower D. When we minus all of those, we've minus 181. 210 minus 181 equals 29 centimetres. So sunflower C is 29 centimetres. Phew. Can you see how just knowing the value of some things, we can gradually chip away and find the answer that we're looking for? For these types of questions, always think, what information have I been given? What is it that I'm trying to find out? It's also a good idea to highlight or underline important information in the original question as well. So did you think you were finished? Sorry about that. We've still got some work to do. So, in this morning's email, you would have got a worksheet solving equations, like the one shown on screen, and as usual, there are 3 levels. So I'd like you to choose the level in which you feel most comfortable, or where you'd like to challenge yourself. I encourage you to challenge yourself. Think about which worksheet which exercise, which task is most likely to grow your brain. You don't want one that's just going to keep your brain comfortably plodding along. You want one that's going to grow your brain and take it to the next level. So choose the one that does that. And then remember, once you've completed your work, we'd love to see it in an email sent to us. If you don't have the worksheet, that is fine as well. Have a look at the worksheet that was sent to you this morning and you can write it down on your piece of paper. So when you're emailing us, I should expect to see work from the lesson, the online lesson you've been pausing and writing down. And we also expect to see the worksheets as well. There's also going to be an extra challenge with some more of those more complex questions for those of you who really, really, really want to push yourself, and those of you who have said, you know, you really need to work on problem solving, these are the questions that are aimed at you. Yeah, that's right, you. And you will know who you are anyway. Remember to email us your work at the email address shown on screen, where we will be patiently waiting. Have a great day, Year 6. Bye.